Like strong acids, strong bases completely dissociate in water, and while acids dissociate protons, bases dissociate hydroxide. Now, the hydroxide anion is typically not very soluble, and although it will form ionic compounds, they generally don't dissolve in water. So the strong bases are the ionic compounds with hydroxide that actually form dissolvable salts. So those are typically group 1A and the heavier group 2A alkaline earth metals. So sodium hydroxide, lithium hydroxide, potassium hydroxide, rubidium hydroxide, calcium hydroxide, barium hydroxide, and strontium hydroxide. So those cations are the group 1A and then the heavier group 2A cations. We see that as ionic compounds, they are all solids at room temperature, and when they dissolve, they completely dissociate into the ions that comprise them. So the cation as well as hydroxide. And just notice that the group 2A cations have two hydroxides, since the group 2A cations have a +2 charge. There are many weak bases, which are usually some form of an amine, and the simplest amine is ammonia. So a weak base will form hydroxide, but just a small amount of hydroxide. And here on this slide, we see ammonia, when it dissolves in water, will accept a proton from water. So that means it's a base, and when it accepts that proton from water, water transforms to hydroxide. And so ammonia is not only a Bronsted-Lowry base, but it is also an Arrhenius base, since it increases the concentration of hydroxide in solution. Notice in this equation the double arrows. That means this is a reversible situation, and on the left, where we have the molecules, is what we actually have more of. There's only a small amount of hydroxide, 5% or less, compared to the amount of ammonia. So that's what makes ammonia a weak base, is that only a small amount of hydroxide forms when it dissolves.